Hello, Algebra. This is a lecture on using square roots to solve quadratic equations. Before we begin this task, we are going to be kind of looking at a more simplified version of this, and then later on, we're actually going to be getting to solving quadratics. The task today is just going to be simplifying square roots, and I actually teach this in Algebra 2 as well. Here's a picture of a slide from Algebra 2. Where I give three different things that need to happen to make sure a radical is just a square root sign, three different things for a radical to be simplified. There can't be any radicals in the denominator, that's one of them. There cannot be any perfect square factors underneath the radical, and then there cannot be any fractions underneath the radical. So all three of these things are important. Today we are only going to be looking at one of them. We're going to be looking at this right here. There cannot be any perfect square factors underneath our radical. So this should be a pretty brief lecture. I don't foresee it being too extremely complicated. Let's start with a little review. You guys should know the square root of 36, and you should also know the square root of 81. To take the square root of a number, what you're asking yourself is what times itself would be this number. So what number times itself would be 36? And hopefully you guys agree that that answer would be 6, right? Because 6 times 6 is 36. Very similarly, I could ask you guys to find the square root of 81. This could be something you type into your calculator, or you could be like, the square root of 81, what number times itself is 81? And you would come up with the number 9. Now, what if I asked you guys to find the square root of 32? Now, historically, what you would probably do is you would go into your calculator and you would type in the square root of 32, and it would give you some decimal like 5.8 something, I'm guessing. And that would be your answer. You'd be happy with that. However, as you get further into algebra courses, you're going to find that that is not an answer that most algebra courses are looking for. Instead, if you're asked to find the square root of 32, what you're going to try to do is you're going to simplify the square root of 32 using these three rules that I outlined earlier, right here. One of which says there cannot be any perfect square factors underneath the radical. What do I mean by that? What are the perfect square factors? Well, the perfect squares are this series of numbers. 1, 4, 9, 16, 25, 36, 49, 64, 81. This is an infinite list. It's going to keep going, but this list, having it written down is going to be helpful for you. 121, 144. Like I said, it goes on forever. So, what we're saying by it cannot have any perfect square factors, the number right here cannot have any of these numbers as a factor. You can kind of disregard one, but none of these other numbers should be factors of the number underneath here. If we're to list the factors of 32, we would come up with 1, 2, 3 is not a factor, but 4 is. 5 is not a factor, but 6 is not either. 7 is not a factor, but 8 is. And then 16, and then 32. All of these numbers are factors of 32. And so, are any of these numbers from this list? And absolutely, right? We have 16, and we have 4. So, that tells us that square root of 32 is not simplified. And our task today is going to be to simplify it. In order to do so, you are going to find any of these numbers that are factors of the number we're talking about. We're talking about 32, and we're going to actually find the biggest factor from our list. 16 is the biggest factor of 32 that's in this list here. And so to simplify the square root of 32, you're going to take the biggest number and what it multiplies by to get to 32. So 16 times 2 is 32. And you're going to rewrite the square root of 32 as the square root of 16 times the square root of 2. One more time, how did we get that? Well, we listed all the factors. We picked the biggest one from this list up here. 16 is the biggest number in this list. And 16 times what is 32? 16 times 2. So this is not our final answer because you actually can take the square root of 16. The square root of 16, of course, is 4. So simplified, our final answer is 4 root 2. Now, all of these numbers are the numbers that you can take the square root of. That's what makes them. If I were to need to create it, it's 1 squared, 2 squared, 3 squared, 4 squared, and on and on. So the fact that 16, right, we have square root of 16, if it's one of these numbers up in the list, you can always take the square root of it, and that's how we're going to get to our simplified answer of 4 root 2. Let's try the square root of 80. So up here, which of these numbers are factors of 80? If you need to list all of the factors of 80, you may do so. The factors of 80 are 1, 2, 3 is not a factor, but 4 is. 5 is a factor. 6 is not a factor. 7 is not a factor, but 8 is a factor. 10 is a factor. 16, 20, 40, and then 80. All of these numbers are factors of 80. What is the biggest number on the list? Once again, it's 16. And then 16 times what is 80? That would be 5. So the square root of 80 could be rewritten as the square root of 16 times the square root of 5. Trying to erase this here so it looks like the square root of 16. There we go. Square root of 16 times the square root of 5. Now this is not simplified because we can actually take the square root of 16, and the square root of 16 is 4. We'd end up with 4 root 5. That's our answer. Let's try a couple more. I'm going to rewrite the factors 1, 4, 9, 16, 25, 36, 49, 64. 14. What are the factors of 14? 1, 2, 7, and 14. What you're going to find out about the square root of 14 is none of these numbers up here in this list are factors of 14 except for 1, and 1 doesn't really count. So the square root of 14 is actually simplified, and I would want you to have that as your answer, not the decimal approximation for it. What about the square root of 90? Well, which of these numbers are factors of 90? Hopefully you're coming up with 9. So you'd rewrite the square root of 90 as the square root of 9 and times the square root of 10. The square root of 9 can be taken. The square root of 9 is 3, and we end up with 3 root 10. We got a couple more. These ones have numbers in front, but don't let that really affect it all that much. So our list of numbers, once again, one more time, 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Which of these numbers are factors of 24? That would be 4, and 4 times 6 is 24. You guys should be able to take the square root of 4, that is 2, so we end up with 3 times 2 times the square root of 6, or 6 times the square root of 6, and that would be our answer. Pause it here, try this one, see how you do. 9, of course, could be written as 9. 25 is the biggest number from this list. That is a factor of 75. 25 times 3. So you'd end up with 9 times the square root of 25 times the square root of 3. The square root of 25 is 5, and we end up with 40. So 9 times 5 times the square root of 3, which is 45 square root of 3. This is pretty quick. You have a worksheet on this, but please feel free to come in and ask me questions if you guys have them. Good luck, and I'll see you guys around.